Hello and welcome to SysCon 2024. I'm Aws Jaber from KTH, Royal Institute of Technology. Today I'll be sharing insight on transforming cybersecurity dynamics, enhancing self-play reinforcement learning and intrusion detection and prevention system. We will look into how self-play algorithm can be significantly enhance intrusion detection and prevention systems, making them smarter and more robust against cyber threat. So join me as we explore this cutting-edge development in field of cybersecurity, and let's begin. So this is a little bit briefing about me. I'm holding a master's degree in advanced computer networks with a PhD in computer science with focus on network security. Currently, I'm doing my further research in the field of postdoctoral research. So let's start it with what's really happened now in cybersecurity world. As you can see, we have here like two images that appears to illustrate two aspects of cybersecurity: the vulnerabilities and defenses. On the left, we can see a circular diagram labeled industrial under attack for the vulnerabilities exposed. So this part of image outlines 7 sectors, each associated with a practical type of cyber threat. So you can see, for example, the finance. On the payment fraud, the finance institutions face like fraudulent transactions. In the healthcare, the data breach. Personal health information is a risk being stolen or exposed. And retail, the e-commerce hacks, online retails platform maybe experience security breaches. For the government, one of these examples, critical infrastructure inside the government that is already used, the cyber espionage. The government are target for sensitive information. And for the energy, we can also think about the infrastructure that targeted. More specifically, nowadays we have a high demand on attacks for in the Russia crisis with the EU. We can find several attempts to expose the infrastructure targeting the energy. On the education side, we have the ransomware attacks. Schools and universities are vulnerable to malware that look access to data until a ransom is paid. For the manufacturing, the intellectual property theft, the theft of the property design and process. On the right side, there is a 10-pointed shape with the tip label 10 ways to strengthen cybersecurity defenses, suggestion, measurement to protect against the aforementioned vulnerabilities. So we can figure out how the best way, starting from strong password, regular updates, multi-factor authentication, employment, training and awareness, of course, secure network, firewall protection, data encryption, incident response, which is we are recently quite take care about that. From our measurement from the intrusion detection and prevention system, we also think about how the intrusion response for that, and security audience and backup solution. Integrating machine learning, reinforcement learning, and game theory to address cybersecurity challenges identified in image can be an innovative approach. So there's some explanation on this slide how to use these technologies and theories can be interplay to enhance cyber defenses. So basically we have the three main components: machine learning, reinforcement learning, and game theory. And machine learning algorithms can analyze vast datasets to detect a pattern indicative of cyber threats such as payment fraud, data breaches, and e-commerce hacks by training on historical data. So the machine learning model can be identify the unusual activities that deviate from norm, thereby alerting organization to potential threat. Reinforcement learning, a type of machine learning, can be particularly effective in dynamic and uncertain environments like cybersecurity. Reinforcement agents learn optimal behavior through trial and error interactions with the environment. In cybersecurity, an reinforcement agent could be trained to detect a threat by receiving rewards for correct identifications and penalties for misses. Over time, the agent learns to predict and mitigate attack more effectively. For instance, the context of cybersecurity, there's a small, very short example for that, and reinforcement agent could be developed within a network to continuously learn from target patterns and identify potential intrusions. Another example that we have, if we have the applications that developed of reinforcement-based system that can adapt it to attackers' strategies by continuously learning from attempt breach and adjusting a defensive mechanism accordingly. While in game theory, this is a study of strategic interaction among rational decision makers. It's especially relevant in cybersecurity when considering the interactions between attacker and defenders. By modeling attackers as games, defenders can predict attackers' moves and develop strategies that minimize risk and impact. So we can think about in loudly how the game theory and reinforcement learning can be very useful in cybersecurity for the multiple scenarios in real time. If we take any kind of the attacker objective and defender objective as well, and make the best optimal strategies for using the reinforcement learning between attacker and defender, and to produce the best optimal strategies and try to maximize the rewards, for example, to, for the defender, we can show that how these are replica or make, let's say, make a clear vision in reality for the cybersecurity officers to improve and optimize their real network, and that the lesson they learned from this like simulated environment. So if we think about the simulating cybersecurity as a game, cybersecurity as a scenario can be formed as a game where attacker and defender have opposite objective. Machine learning can be analyzes the past attacks to predict future ones, while reinforcement learning can help in devising strategies that improves defenses over time. While in adversarial machine learning, by using game theoretical approach, we can design a system that anticipates and responds to tactics of attackers, who may also be using machine learning to breach defenses. That involves creating models that are robust against adversarial attacks, and while in the enhance of the incident response, the reinforcement can optimize incident response strategies by simulating various attacks scenario and learning from outcomes. Game theory in principle help to understanding the payoff for different response strategies and choosing the most effective one. So as you can see on this slide, we have the adaptive cybersecurity that's very trendy nowadays actually. The challenges in the dynamic landscape are multifold. We need to have to stay a step ahead of the cyber criminals who are continually refining their method to exploit the vulnerabilities. Our goal is not just to respond to the threats, but to anticipate neutralize them before they can be cause harm. To achieve this, we are looking at automating security tasks, allowing AI-driven systems to handle the routine, while also adapting in real time to the changing tactics of attackers. This is where game theory became invaluable. It allows us to model the interactions between attacker and defender as strategic game. So many approaches are still in developing actually, and our approach is to use the model to inform the development of intelligent systems that can be think several moves ahead, such as much like a ground master in chess, for example, that will be using game theory. By simulating countless scenarios, these systems learning to predict attacker behavior and adjust their defenses accordingly. With the strategy, we are not just building strong defenses, we are striving to build adaptable learning systems that evolves as the threat evolve. This is the future of the network security proactive actually, with intelligent and ever the vigilant. So in related works, we can see that the summary covers the interplay between national security for that advancements in artificial intelligence and game theory. Following of the attacks of the September 11, 2001, the United States amplified its focus on national security by establishing the Department of Homeland Security (DHS), aimed at bolstering domestic proactive measures. Parallelly, the field of artificial intelligence, practically in the gaming, saw significantly advancements with the development of the AlphaGo Zero by DeepMind, AlphaGo 0 represents a milestone in self-play reinforcement learning, starting without prior game knowledge and progressively enhancing its capabilities by playing against itself. So also in literature review also explores the convergence of game theory and reinforcement learning in decision-making process. Game theory rooted in economics and mathematics deal with the strategic environment where all our outcomes are depends on actions and multiple decision maker. Reinforcement learning, on the other hand, involves agents learning to make optimal decisions through a trial and error process motivated by reward or penalties, hence focusing on adaptive strategy development and based on experience. Furthermore, the application of game theory infrastructure security is discussed. You can find more information or literature review for this paper, with example including urban rail security, partial strategy, and strategic elements of terrorism such as suicide bombing and targeting killing, and optimization of terror response facility are analyzed, demonstrating practical application of these theoretical models in real-world scenarios such as patrol planning for U.S. Coast Guard. The complexity of the security games involving multi-objective consideration at the dynamics negotiable between terrorists and groups and government are also highlighted. Overall, the text, in literature review, it's underscore the critical importance of protecting nations from threat through advanced security measures and innovative application of game theory and artificial intelligence enhancing these efforts. So, till this slide for the outlines, we talked about the cybersecurity and the current trend on cybersecurity, machine learning, why it's important, then why reinforcement learning is very trend and very comprehensive use nowadays, and the game theory. So to sum up these things, on this slide I'm presenting my outlines for this paper. I have a use case that the infrastructure that used, the reinforcement learning problem and the development, what kind of method, and the results with a conclusion. So in our use case, intrusion prevention, a defender owns a network infrastructure and the attacker seeks to intrude on infrastructure. As you can see here, the content display the what likely of the list of use cases of components of the Markovian or Markov game model applies to intrusion prevention and network infrastructure. So this particular use case for the component of the basic diagram as shown here for the network structure consisting of the following elements. It might be counted to router switches, servers, and database, for example. So this is a part of large presentation. Later on we'll discuss about how Markovian game model can be used to simulate and prevent intrusion detection and prevention system and network infrastructure. Just in a briefing, a Markovian game model is a type of mathematical model that combines elements of Markov decision process and game theory to handle situations with the multiple interacting decision maker often under uncertainty. In this context, the model could be used to anticipate possible intrusion attempts and developing strategies for preventing them by considering the actions and counteractions for both network defender, for example, security software and administrators, and possible attackers. These slides present a continuous of second part of presentation of Markovian game model for intrusion prevention. So this section introduces a graph model as a part of a system graphs, represented by G, which is equal to N and E, where N is the set of nodes and E is the set of edges, are a common mathematical abstraction used to model relationships and interaction in the network in the context of the intrusion prevention. A graph can be represented in the network infrastructure and the possible paths to introduce might be take. So this is why the Markovian representation here and why the graph is used. The representation of network structure, not surprisingly, the nodes denoted as a N can be representing different entities within the network, such as a server, workstations, database, or any network devices. Edge denoted to E, which is representing the connection of the potential pathway between these entities. Modeling intrusion pathways, the graphs allow security analysis to visualize how the intruder might be navigate through the network from the entity point, as shown to the start, the end start, to the target, such as sensitive data, shown as the end data. Analysis security measure by understanding the graph structure. Analysis can be determined the most vulnerability point in the network and prioritize security measure accordingly. In the Markovian decision process, the Markovian decision model, decisions are made at various point nodes based on the current state and potential actors, edges leading to the other nodes. The graph structure naturally lends itself to this type of analysis. Simulating attacker and defender strategies. This graph can be used to simulate interactions between an attacker trying to infiltrate the network and defenders' efforts to prevent it. Each node edge can be associated with the probabilities that represented like likelihood of attacker moving from one node to another and forming defense strategies. For thus, we need to think about the optimization resources by modeling a network as a graph. It's possible to apply algorithm that can be most effective way to allocate resources for intrusion prevention, like placing intrusion detection system or deploying security personnel. This slide is the third component of Markovian game model for intrusion prevention, representing by label the state S. The state space of Markovian decision process, the MDPs, or games, representing all possibility states that the game can be in. The context of intrusion prevention, each state would represent a unique configuration or status of the network at given time. So here the state space is given by the complex formula S, which is read as the coordinately of S, referring to the number of elements of the state space of S, W plus 1, which is a space formula for the complex where W and M likely representing the specific parameters of the network on the game model. This formula would be used to calculate the total number of potential states and the model, which could be quite large. Given in nature, a network can be a various way an intrusion can be occur. Additionally, it depicts the several example states, denotes that the SA and SD for the which may be represent state for representing the attacker A and the defender respectively, each state represented by a vector of numbers which could be corresponding to different network variables or conditions relevant to the intrusion prevention. For example, S, A, and 0, S for the attacker 0 and S for the defender 0 are both with a set of zeros which might be represent the initial state of the network where no attack has been launched and no defenses have been triggered. S1 for the attacker and S1 for the defender, which shows the vectors which could be representing a state after certain actions have been taken by the attacker and corresponding response by defender. The response of the defecting states in such as detail can be run in simulation or compute strategies that likely into account every possible situation that could be occur with the networks. The comprehensive approach is essential to understanding the dynamics of the network security and training systems to automatically detect and respond to potential threat. Now let's take a look on the automatic learning for security strategies that employed by Markovian process for Markov game model, of course. So for this model allows us to represent the analysis interactions between attacker and defenders as a stochastic game with a state space that evolved particularly powerful in scenarios where the environment is uncertain or where the actions of the attacker and the defender influence the state of the system. Then we move on the motivation for using reinforcement learning in the context. Reinforcement offers a framework where agent learns to make a decision by interaction with their environment is driven by concept of reward feedback, positive reinforcement learning for success actions and negative reinforcement learning for unsuccessful ones. In the realm of cybersecurity, this means that the system learns to detect and respond to threats more effectively over time. We are not just programming static defender rule. We are nurturing a system with evolving by learning from a new data and adapting its strategies. A system that grows smarter, that more is challenging. The ultimate aim is to create a cyber defense mechanism that is proactive, self-improving, and can be anticipating with the next move of the cyber adversaries. In our proposed approach, we explore how Markov decision process and their extensions like partially observed MDPs, POMDPs are applied to network security, especially in enhancing IDPS. The proper discusses the formal structure of MDPs are partially observed Markovian decision processes, their decision-making process under uncertainty and challenges for determining optimal policies through belief state updates. It further delves into the reinforcement methods, including a value-based, a policy-based, and there's other like several, for example, model-based actor critic, and advanced algorithm like TD3 for developing a dynamic cyber strategies against cyber threat. Additionally, and this paper covers Markov game as a framework for modeling multi-agent interactions and network security, providing insights into competitive dynamic between network defender and attacker. The effectiveness of these approaches is evaluated through enhanced self-play and policy reinforcement, including significant improvements in threat detection and response over traditional security mechanisms. So, our proposed approach will be examined over an attack steps, sequences, and profile, which attack process to begin the reconnaissance, where attacker explore the infrastructure to identify vulnerabilities, practically scanning the nodes with the low defense attributes. This followed by exploiting vulnerabilities where identify vulnerabilities are exploited to compromise nodes. In the progression phase, attacker having a compromised node again and gain insight into network topology and enabling further exploitation. For the final step, the target compromise, attacking a crucial node or data to complete with the intrusion. The attack profile generally exhibits a deterministic nature, with the policies focusing on reconnaissance and explosion of vulnerabilities. However, when faced with a dynamic opponent policy, a stochastic, suggesting various actors with a significant probability in certain state, indicating adaptively to counter deterministic defense strategies. On the defensive side, the strategy involves handling a critical nodes and patching vulnerabilities, and defender can be learned to anticipate and respond likely an attack pattern. In this slide showing the features of the twin delayed deep deterministic policy gradient, the TD3 algorithm, which is that I'm proposing for this paper. This algorithm is the advancement in reinforcement learning that addresses some of the issues found in earlier reinforcement technique, such as deep Q learning and deep deterministic policy gradient, the DDPG. So as you see, the left side of the slide provides a consensus outline of the TD3 algorithm steps in the pseudocode. It starts with the initializing actor and critic networks, which are a part of the algorithm architecture that help in selecting actions and evaluating them. Respectively, the algorithm proceeds through several steps that involve observing the current states, selecting and executing an action, storing the transition, and sampling the patch from the replay buffer to update the network weights. The process of the iterative and deals of the agent that learn a policy strategy of actions to maximize the expected return, which is the cumulative reward it receives. The delayed part of the TD3 refers to the ideas that the policy updates are less frequent than the critic update, which is held to stabilize learning. On the right side, you have several graphs that likely show the performance of the TD3 during the training. So, for example, the likelihood of the successful hack, this might be indicate the probability of the agent successfully completing its objectives over time. It seems to be compared between training scenario and evaluation scenario, with the training likely involving into learning and adoption, while evaluation tests the learning policy. Cumulative rewards shows the total rewards accrued over the time during the training. In reinforcement learning, the cumulative reward is a crucial and critical indicator of how well the agent is learning. The average episode length, this might refer to the average number of steps taken per episode. And the context of the cybersecurity, an episode could be simulated intrusion attempt or defensive scenario. So, and overall, you can see the more information inside the paper about the performance of attacker and defender agent, possibly that demonstrating how the TD3 enables the agents to learn and adapt to each other over time.